Okay, here's the homework explanation for chapter 12 homework. So this is the first question with the tugboat, and I started by drawing a free body diagram, and by using the free body diagram and the weight and the mass, I was able to find a of x from the given equation of F equals that, and then a of x is force over mass, and then I was able to plug that in down here into my kinematics equations of a of x equals dv over dt, and took the integral of that, and then plug that in. I was able to find the time of 18.4 seconds. And then for B, trying to find the distance traveled, I was able to take a of x again and just change that kinematics equation, and then take the interval of it, well, the integral, not interval, and then plug that back in. I got a total of 36.19 meters. Sorry, 36.14 meters. Can't read my handwriting. And then to go to the next one with the truck and the pallet and boulders, I messed up on this one by, I was using just gravity's 9.8 and forgot to change the weight of the pounds into mass, so kind of messed up on that. But to follow the process, I first found the tension of the vertical components and then plugged in, but I messed up for and used normal gravity, and then plugged that in to find my tension. And then from that, I was then able to find the stuff with the truck, and that then ended up being a force of 11,000 pounds, which I know was wrong. And then from there, we had, for part B, I had to find the contact force between the pallet and so again, I messed up, so kind of it's hard to explain it. But I was able to take all the masses and then find the force and go from there. And then for 12.36, which is the one with the kids playing tetherball, this one, I was easily just to be able to find the force in the y direction and the distance away from the pole, and then that was able to help me find theta, which, I mean, that was the angle, then theta was right here. And then to find B, which was the tension of the cord, I then just had to, where is it? Right here. Then just had 2 times my mass of the ball and gravity by theta, which was I found up here, and then that gave me a total tension of 6.85 newtons. And then for 12.44 with the crane and the wrecking ball, so up here I was just able to find, for when it was stationary, I just found the tension of the line, which was moving, so it was back to statics, and just taking my forces and using the weight and the cosine of that to find the tension of the vertical component. And then to find the tension of it moving, I took the weight and then multiplied that by the velocity and the length of the line. I guess took the weight and then added that to the weight times the velocity, and divided by the length of the line, and got 145.6. And then for the turntable of 12.57, I first started by finding the forces and just kind of used those equations, took that, then took square root of it, and then I tried to find the force in the y, and which equaled 0, and then the normal force minus the weight, since it wasn't going anywhere in the y, normal force and weight equal each other, and then I used that to then find, because then n equals the mass times the gravity, which then I was able to plug back in down here to help me find the coefficient of friction, and that just times the gravity by the square root of the speed of the acceleration and the velocity by the distance away from the center of the turntable circle. And that gave me a final static friction of 0.236. And then for Venus and the Sun, I took the orbit equation from physics, and that was gm equals radius times velocity squared. And then I was able to plug the radius and velocity given in to giving the radius of the orbit. And then using that, I then plugged my found GM in to find the mass of the Sun, which was GM over G, using the coefficient of, well, using the give-in of the gravity. I was able to find the mass of the Sun, which was 1.998 to the times 10 to the 30th kilograms. And then to find the gravity, the acceleration on the surface of the Sun, I was able just to take also the given one of gm times radius squared, which equals your weight. I was just able to plug that in, and then gravity, and then g was equal to 276 meters per second squared. And then for the first oval one, trying to find the initial velocity and making it work, I took the 12.35 equation and used the 12.37 equation to slowly work my way down. But the equation given was R naught to 2 cosine of theta, and I was able to plug that in for my r's, and the equation of u equals 1 over r, which then equals 2 cosine, which is up here. And then by taking the derivative of that, I got sine of theta over r of theta, and then by scoring that, I got cosine of theta over r of theta, which then plugged back in to, by 12.37, it then became F equals 2mh u2 over 1 over r, and over r of theta, which ended up being that F is proportional to 1 over r squared, or is inverse to 1, at least to r squared. And then for the satellite, to find the change in speed for it to go out, I used the gravity equation again by the radius, and that gave me the radius of Earth to the outside the orbit, the original one. And then I took found the circular velocity and the straight velocity, and then it was just subtract those apart to get a velocity change of 1.367 to 10 to the 3rd meters per second. And then for the satellite in orbit, to prove the equation, I So given we had 1 over p equals 1/2 times 1 over r theta, well, r naught plus 1 over r1. And so then using equation 12.39, which is over here, I was able to get, so 1 over r1 or 1 over 0 equals, and then 1 over b or 1 over r1. And by taking the cosines of those, rb ends up being the inverse cosine of r1, so those cancel out, which then means that r1 plus r2, well, r0 plus r1, or ra plus rb for the equation, then equals just the 2 times of gm over h squared. And so I'm plugging that back into the original one of the kinematics equation of an equals v squared over p, but then that also equaled h squared over r squared of p. And then the force equaled gm times mass divided by r squared, which equaled mass times acceleration, and the acceleration equals the nh squared over r2 squared, r squared p. And then by then just substituting things in the equation, I then was able to prove it by 1 over, that equals 1/2 of RA plus RB. And that is my homework 2.